Okay, we are on Unit 2, Section 3, Review Number 3. Some of my classes did not get through page 200, number 7. So that's where I'm going to start, page 200, number 7. Go ahead and pause the video where you need to pause in order for us to go ahead and do this. So, it says write each equation in function notation for number 7. So number 7 looks like this. If I need to write my function notation for number 7, it says write the equation, so I have to find the equation first. In order to find the equation, I need slope and I need the y-intercept. They give me 2 points, so I can go ahead and I can use 2 points to find the equation, or I already know what the y-intercept is, and I know what the slope is. My y-intercept is at -2, and then what I have to do is I have to go up 1, 2, 3, 4, 5, 6 over 2. So up 6 over 2 is my slope. So my equation turns into y equals 6 over 2x minus 2. 6 over 2 could be reduced to 3 over 1. So 3 over 1 is the same thing as 3. My equation becomes y equals 3x minus 2, and I can translate that into a function. F of x equals 3x minus 2. Page 186, number 24. Page 186, number 24. On page 186, number 24. Suppose y varies directly as x. Write a direct variation equation. So, first thing is this. Direct variation means y equals mx plus b. Direct variation means there is no plus b, it's 0. So I'm going to go ahead and I'm going to use this equation. This is what a direct variation equation looks like. Then they said that y is 6 and my x is 10. So what I'm going to go ahead and do is I'm going to divide by 10. That gives me 3 over 5. So I actually know what my equation is. Y equals 3 over 5 x. Then it says find x when y is 18. So now I can go ahead and I can plug in 18 and solve for x. Multiply by 5, multiply by 5. 5 times 18. Five times 18 gives me 90. Divide by 3, divide by 3. 30 equals x. Page 229, number 24. Page 229, number 24. 24. Here we go. It states, in 1904, a dictionary cost 30 cents. Since then, the cost of a dictionary has risen an average of 6 cents per year. Write a linear equation to find the cost C of a dictionary Y years after 1904. So here we go. I have to find an equation, y equals mx plus b. That means I have to find the slope and I have to find the y-intercept. They actually give me the y-intercept because 1904 is where we started and my dictionary actually cost 30 cents. So I know that my y-intercept has to be 30 cents, 0.30. That is my 30 cents. Okay? Since then, the cost of a dictionary has risen an average of 6 cents per year. 6 cents per year. There's my equation. Write a linear equation to find the cost of C of a dictionary Y years after 1904. So X actually stands for years, but they want me to change that to Y. And then they say C actually stands for the cost. So this actually turns into my cost. 0.06Y plus 0.30. So here we go. It says write a linear equation. If the trend continues, what will the cost of a dictionary be in 2020? So we started in 1904, and now what they want is to know what is a dictionary going to cost in 2020. Well, I have to go ahead and I have to find how many years this is. I can't plug in 2020 because this is years since 1904. So 2020 minus 1904 gives me 116. So this is going to be in 116 years later. So my cost is going to be 0.06 times 116. That gives me $6.96 plus 30 cents. Plus 30 gives me $7.26. So my cost is going to be $7.26. Here we go. Page 222, number 61. It says a telecommunications company sold 3,305 smartphones in the first year of production. Suppose an average, there you go. A telecommunication company sold 3,305 smartphones in the first year of production. Suppose on average they expect to sell 25 phones per day. Write an equation. So I need to write an equation, y equals mx plus b. So we started at 3,305 phones. And then it says 25 phones per day. Okay? But then it actually tells me we have to have P for phones and T for years. So I know this stands for years because it's 25 phones, per day. So this turns into, so they want T for years. They're trying to trick us. If this stands for days, I need to take 25 times, or actually years. So if there's 365 per year, 25 per day. So I would take 25 divided by 365 because there are 365 days. So I had to divide this by 365. Man, they're trying to trick us big time. So my slope actually becomes 0.068 per year. So now this turns into years. And I started at 3,305. This is a tough question. But they actually want the y to turn into p, and they want my x, which is years, to turn into t. If the sales continue at this rate, how many years, so I need to solve for t, sell 100,000 phones. 100,000 phones, 0.068t plus 3,305. So I'm going to take away 3,305, take away 3,305. So 100,000 minus 3,305, 96695 equals 0.068t. Divide by 0.068, divide by 0.068, divide by 0.068 gives me oh shoot. I apologize, guys. La, 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 la. What, Mr. Bourne? I screwed up. It's not 25 divided by 365. If this is per day and there's 365 days a year, we take 25 times 365. 9,125. This turns into 9,125. That's my slope. 9,125. 9,125. This is a tough question. I apologize. So instead of dividing by this, I'm going to divide by 9,125. 9,125. 9,125. So 9,6695 divided by 9,125 gives me 10.59. So it's going to take about 11 years. Once again, let me go ahead and re-explain this. This was 25 per day. If I have 25 phones per day and there's 365 days a year, I multiply that instead of divide. So then this turns into years. Then I go ahead and I continue. I apologize for my mistake. Now we are on page 195, number 39. Number 39. It says, find the formula for the nth term of the arithmetic sequence. -7, -4, -1, 2, ... So in order to find the equation first, I need to go ahead and label 1, 2, 3, 4. This is my value. These are my terms. Now I have 2 points. If these are my 2 points, I go ahead and I find my slope. -4 minus -7. 2 minus 1. 3 over 1. So that's 3. My equation now turns into y minus -7. 3 times x minus 1. Y plus 7 equals 3x minus 3. Minus 7 minus 7. Y equals 3x minus 10. So this is the same as a sub n equals 3n minus 10. We translate it just like I taught you. So this would have to be letter H. I'm going to pause the video now, and then I'm going to go ahead and make a part 2.